All right, so example 2, we actually get to do a little bit more interesting math than the just boring area and circumference of a circle. Here it says find the distance from the center of a circle with diameter of 26 inches to a chord of length 10 inches. So first thing we have to do is make sure we know what this looks like. So we draw in a nice circle, as nice as you can. Get the center of your circle. All right, so for doing this, I would start by drawing the chord. The chord has a length of 10 inches. So remember, the chord does not pass through the center of your circle, just goes from one point on the circle to another point on your circle. And then it says we want to find the distance from the center of the circle. Here's the center of the circle to the chord. So you're always going to draw the distance from the center of a circle to a chord. We're looking for the shortest distance. Remember, we had a definition that said that formed a perpendicular angle. Now, the other thing that's going to help us out is we were told that this circle has a diameter of 26. Our goal is to try to form a triangle of some kind. So really, you could draw the diameter in anywhere, as long as it's passing through the center. But if we pass through the center so it forms a triangle with the chord that we already have, that's going to be the most helpful to us. So there's my diameter right here. Now if this whole thing is 26, we know that each side, so if I split it in half, I have the radius. Each half is not going to be 26, it's going to be 13. Alright, so the other thing that we want to remember is when you have a chord, so the pink line is our chord, and you're finding the distance from the center of the circle to the chord, it creates the perpendicular line, and it also creates congruent segments. And they told us that the whole chord had a length of 10 inches. So if the whole chord has a length of 10 inches, that means that each segment is 5 inches long. Alright, so I'm going to focus on this triangle that we formed. Remember, our goal was to have a triangle. I'm going to redraw it. Looks something like this, where here's the 5, here's the radius 13. Maybe I should have tilted it a little bit. Can you see how it just rotated this way a little bit to look like that? And what we're trying to find is x. And x is going to be this missing side. Alright, from here you actually have two ways to solve this problem. If you remember your Pythagorean triples from chapter 9, you might recognize that this is a 5, 12, 13 triangle, meaning that x equals 12 because that was our missing side. You had the 5 and you had the 12. I'm sorry, you had the 5 and you had the 13. It's a right triangle, so you can use a Pythagorean triple. If you did not remember that, that's alright. You can fall back on the Pythagorean theorem, which is just more work, but will get us the same answer. So Pythagorean theorem, 5 squared plus x squared equals, remember the hypotenuse is on the other side, 13 squared. So we have 25 plus x squared equals 169. Subtract 25 from both sides, and we have x squared equals 144. Square root both sides, and you will get x to equal 12. Then I forgot we are in inches on this circle, so 12 inches, which means up here we have 12 inches as well. So that is the distance from the center of the circle to the chord. It forms a perpendicular line and it bisects the chord. Our goal is to figure out what triangle we can use to try to find for the missing side.